Okay, we are on to 2.8, and this is part 1 of 2.8. We're going to start with example 1, and we're going to be learning how to graph a polynomial inequality using a sign chart. Okay, you can actually make the graph of this once we find this out too. So here is my polynomial. So I look for my zeros. I know I have one at -3 because of the x plus 3 factor. X squared plus 1 never equals 0 in the real numbers. X minus 4 means I have one at 4, and it's got a multiplicity 2, so it's going to bounce off that axis. So I've got 2 zeros here. And I want to know, when is this 0? Well, -3 and 4. When is it positive? And when is it negative? So I'm going to make what I call a sign chart. That's going to be positive and negative signs. I put my zeros on my sign chart. Over here, I'm going to plug in a number like -4. And I'm going to plug it into each of these 3 parts and figure out what the sign is. -4 plus 3 gives me a negative. -4 squared plus 1 gives me a positive. In fact, anything squared plus 1 will always give me a positive. And -4 minus 4 squared is going to be a negative squared, but that becomes a positive. So 3 negatives, or 1 negative and 2 positives, makes a negative, telling me that my graph is below the x-axis when I am less than -3. When I'm between -3 and 4, let's pick an easy number like 0. 0 plus 3 is positive. 0 squared plus 1 is positive. 0 minus 4 ends up being squared. That's still positive. That comes out to a net of a positive. So I'm above the x-axis between -3 and 4. As I plug in and get these signs, I'm getting whether the y-coordinate is negative or positive. And I pick a number like 5 to the right of 4, and I get positive for all of them. 5 plus 3 is positive. 5 squared plus 1 is positive. 5 minus 4 is positive. Telling me my function is going to look something like this. If you use a graphing calculator, you'll see there's a few more things here. But I can tell that my function is going to go through here and bounce off. I know it bounces off because of the multiplicity 2 at 4. Yeah, you don't necessarily know from your graph what's happening here in the middle, but you know it's positive. And you can generate this graph without the graphing calculator from using a sign plot. Example 2, we're going to go into an inequality, and we're going to find out when this is true from a sign plot. So I have 2x cubed minus 7x squared minus 10x plus 24 is greater than 0. So I need to find some zeros. Okay. I know my options. This is going to be kind of a long list. All the factors of 24. 1, 2, 4. Oops, I missed one. 3 is a factor of 24. Plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. All of these over the factors of 2. So these, my whole list right now is over 1. And I need to write my whole list over 2. The good news is I don't have to write very many of them over 2. 2 over 2 is 1. It's already in my list. 4 over 2 is 2. It's already in my list. 6 over 2 is 3 in my list. 8 over 2 is 4. 12 over 2 is 6. 24 over 2 is 12. And I'm going to start with synthetic division with 1, -1, 2, -2, 3, -3. It's going to take a hint to save a little time that we're going to start at 4. Because I happen to know that 4 is going to work. The only reason I know that is because I looked at the book. 2 times 4 is 8. 8 times -7 is 1. 4 times 1 is 4. -10 plus 4 is 6. -6 times 4 is -24. And then I have 2x squared plus x minus 6. And that is going to be, that factors into 2x minus 3. Again, I'm looking at the book here to save some time. 2x minus 3. You could use the quadratic formula to get 3 over 2 for that. Well, that's plus or minus. And x plus 2. I suppose I would have gotten one at -2 as well. And I have x minus 4. So these are my factors. I am looking for when it is greater than 0. That means this polynomial is positive. So my sign plot, I've got -2 for this one. This is 3 over 2. That's 1.5. And this is 4. I'll start over here. I'm going to put them below just for space. With a number like -3. 2 times -3 minus 3 gives me a negative for the first one. -3 plus 2 is negative for the second one. -3 minus 4 is also negative. This is a net negative. It is not greater than 0 here. From -2 to 3 halves, the easiest is 0, giving me -3, which is negative, +2, which is positive, and -4, which is negative. This makes a plus. Hey, that's part of my, it's going to be positive there. That's greater than 0. Let's do 2. 2 is pretty easy. 2 times 2 minus 3 is positive. 2 plus 2 is positive. 2 minus 4 is negative. One negative makes a negative. So that doesn't work out. And then 5. Usually they switch, but it's best to check anyways. 2 times 5 minus 3 is positive. 5 plus 2 is positive. And 5 minus 4 is positive. Again, I've got a positive. So my answer is a couple of intervals. Because this is strictly greater than, I do not include -2 and 3 halves. But from -2 to 3 halves, it is true, it's greater. And from 4, and it goes forever that way, so it's 4 to infinity. Again, make sure you're going left to right on the number line with your interval notation. So -2 to 3 halves, 4 to infinity. We're going to do one with the graphing calculator. So this is example 3. So I'll enter that into my graph. So this is what they give me. X cubed minus 6x squared is less than or equal to 2x, 2 minus 8x. I could enter those as two separate ones. It's probably easiest to just set it equal to 0 by adding 8x to both sides and subtracting 2. And now I'm looking for when it's less than 0. So that's when is it negative. So I'll put that in my graphing calculator. I'm gonna zoom 6, standard zoom. Okay, and there's my graph. So I can see that it's negative here and here. So I got to find those zeros. No. And so I got 0.32. So it's to the left of that. So this is negative infinity to 0.325. Please give me 3 decimal places. And then I got to get these other 2 zeros. This is inclusive. So I should have a hard bracket on this one. 1.461, 2, 4.21. Again, 1e to the negative 12th, that's 0. 4.214. And this is my solutions. Again, because it's or equal to, I need the brackets. Okay. Some of these are going to be kind of strange. Okay. So we're going to look at a couple that are a little bit strange. Clear it out. So look at this graph. I guess I should move it a little higher. um, so oops, that wasn't the one I wanted to change. I did not need to change my X max. I need to change my Y max. 220. Oh, it's 1, not 10. Okay. So I can look at this and I can ask you, when is it greater than 0? Well, it's greater than 0 all the time. This is always greater than 0. Part A asks, when is it greater than 0? The whole plane, negative infinity to infinity. When is it greater than or equal to 0? Still the whole plane. We're going to answer this about the next one too. C, when is it less than 0? Never. When is it less than or equal to 0? Never. We see that there is nothing that touches the x-axis or is ever below it. Okay? So yes, this is never less than or equal to 0. Now we're going to address one that is a little different. This one Oops. I'm typing all kinds of things I don't mean to be typing. Wish I could use my keyboard for this, but it doesn't work. So I have to use the calculator's keyboard. This doesn't show as much as I'd like it to. So I'm just gonna make my Y max like 75. They did 100. We'll do 100. All right. It would look a little nicer if I'd make my Y scale here 10. That looks a little nicer. I do believe this simply bounces off the axis. Okay. It's also something that I should check. So in order to check that, let's zoom in on a little bit. Negative. Nope, I can't do that. Negative 5, 5, -1. Nope, gotta use the negative button. Don't use a minus for a negative button on these. It does appear that it just bounces off. So we're asked, when is it greater than 0? I need to find what that point is. And I can actually type in a left bound since it's so small. -3. Right bound, I'm going to go, we'll just go 0. That's fine. I don't know why that didn't work. Hold on. Let's try it again. Looking for a 0. Left bound is -3. Right bound is, let's say, -2. And it's -2.5. Well, that was kind of a nice one. It was nicer than I was expecting it to be. So A, it asked me, when is it greater than 0? Well, it's greater than 0 everywhere but -2.5 or -5/2. So I must actually break it at 5/2. It's greater than or equal to 0, though. When I include 0, it's all of these. It is never less than 0 still. And it is less than or equal to 0 at 2.5. Okay? We're going to go back to doing a couple by hand. We're going to do a rational function by hand. And this isn't a whole lot harder. R of x equals 2x plus 1 and x plus 3, x minus 1. For my sign chart now, I'm not just using, and we're going to find when it's 0, undefined, positive, negative. Okay. So when it's 0, that's when the numerator is 0. That's -1/2. When it's undefined, that's when the denominator is 0, 1 and -3. Whenever we have a sign change, when it's positive, so my sign chart, I'm actually going to do all the parts. So take -4, for example. For something to the left of -3, I get negative on top, I get negative, and I get negative, which produces a net negative. So it is negative. from positive is going to be C. So positive, and then we'll do negative. So negative goes negative infinity to -3. Probably positive in the next one. Let's do -1. 2 times -1 plus 1 is -1. -1 plus 3 is a positive. -1 minus 1 is a negative. That's a net positive. Two negatives, negative over a negative makes a positive. So -3 to -1/2 is positive. It's probably another one of each of these. We'll do 0. 0 is positive. Positive, negative. One negative makes a negative. So from -1/2 to 1, we're negative. And let's do 2. 2 is positive, positive, positive. 2 is to the right of 1, so I'm looking in this region over here. It doesn't cross the axis or have any vertical asymptotes, so any value will have the same sign. And 1 to infinity is positive. Part of why these sign charts work is the only place you can't switch from positive to negative without either crossing the x-axis at a root, that's my 1/2, or jumping somehow. And the only way we can jump with these type of functions is without having a piecewise function, really. The only way to jump is to have a vertical asymptote. We're going to combine rational inequality. We're going to do this one where we have to combine stuff first. And I'm leaving some extra room for the process of combining. I'm looking for less than 0. I need a common denominator, which is going to be x plus 3, x minus 1. So the right term I'll multiply by x plus 3 over x plus 3. X plus 3 over x plus 3 is equal to 1. So I can multiply anything by it. My left one I'll multiply by x minus 1 over x minus 1, which is also equal to 1, so I can multiply anything by it. Giving me 5x minus 1 over x minus 1, x plus 3, and 3, x plus 3 over x minus 1, x plus 3. That gives me 5. Now I've got a common denominator, so I can combine my numerators. 5x minus 5 plus 3x plus 9. Eight x plus 4 over x minus 1, x plus 3. Now I can just make my sign chart like I did before. My top is -1/2. Actually, this is the same one I just did. So I combined them. I ended up with the same thing I just did. So my answers are still the same. Okay. When is it less than 0? That's negative. That's this. Okay. That is part 1 of section 2.8.